Hey, what's up? We're back. Let me clean all this stuff up first. Then we can continue. Wallpaper engines freaking out on me real quick. Hold on. I also need to fix the chat thing. Let me get some music on so it's not just my isolated voice. I think 5 minutes is good. Oh my god, I did it again. I'm what you call an idiot, by the way. So I need to restart wallpaper engine is what I'm saying. There we go. Okay, got that fixed. Now we deal with the YouTube thing. Okay, now that we got everything like that cleared up, what we can do now is we can get started. Okay, I don't need all those theatrics. Okay, hold on. Okay, let there be light so I can see. Thank you. Okay. Unit 4. That's where we're at right now. No song playing. I think you're wrong. Come on. I know you got it. No, you don't got it. Okay. We're gonna fix this thing real quick. Chrome. Notice how Chrome is playing something right now. I gotta clean out my tabs, by the way. Notice how I got a lot of videos here, apparently. There we go. See, now it says Food Mart. Okay, now we are ready to begin. The day length is increasing at a rate of 3 days per minute. Holy. That's what I thought. Tomodachi Life is like my thing, bro. PB&J sandwich. I stand for peanut butter jelly. Playtime with Percy too. That reminds me. Hold on.
This is Mr. Alexei Pozitlov.
What happened? How person? Hold on. What is it called? Give me un minuto. On a side quest. Okay, I hope Discord doesn't pop up on my main monitor. Don't you love it when, you know, whatever. That makes sense. Okay. Oh, I love this song. The rate of change or the rate of change of people? Okay, second derivative. No. Boom. Okay, this is position. Boom. Physics, baby. I learned it before. Yeah. And this is velocity. We're slowing down, so now you're neither speeding up or slowing down. You're speeding up, you're speeding up. Actually, here you're slowing down. See, why do they explain slowing down? Oh, they qualitatively instead of quantitatively. Not moving. You're moving backwards. You're moving forwards. You're moving backwards. Boom. Yum. Infamous drawing pad. Take the derivative. Think of it like this. So the rate of change, so you have your distance, right? So let's say your feet. The rate of change will be feet per unit, aka velocity. And so velocity is the rate of change of distance of your, and then acceleration is the rate of change of your velocity. So then you can just take the derivative again, if that makes sense. At 1, that's just going to be 4. It's moving to the right. No, acceleration, that'll be double derivative. Acceleration is 6. It's a constant acceleration. I don't know where I got 6. It's 4. With the free throw. Okay, so it would be 12. I should be able to do this one in my head. Let's see, 25. 25, 35, 40. Oh no, hold on. They're missing a few games in here, but I guess those aren't part of the original meme find. There's Find Me too? Hold on. Twice. Okay. I get it now. Only beat me once. The sales bunny. How could Nintendo Music be so jolly and they gatekeep it behind like $1 million bucks? That's rain. I need to get my math checked. Holy. This is what happens when you don't pay attention. I have an idea. Hold on. Hold on. There's ooh, let me find it. Hold on. Let's see, where did I put it? I made this thing. Let's see. Step one would be finding the photos I used for it. It was a grand total of 2 photos, so it shouldn't be too hard to find. I think. Hold on, give me 1 second. We're gonna figure this out real quick. Oh. Okay, so we just need to find the photos. So we're gonna do that real quick. Is this it? No, I use it for different things. You'll see what I'm working on in a second. If I can find it. Is it raining outside? Looks like it might. Found it. Okay. Need you to... Oh, it was in there already. Oh, was this just... Okay. Okay, well, here, look. I'm gonna turn off my camera and I'll show you what I was working on as soon as I can find it. This will just let me relax because, no offense to anyone, but having a camera on you all the time is a little tiring when you're just doing math and not anything else, you know? almost there. It's in stuffs. Boom. There we go. This is what I was looking for. This is what I was looking for. Yeah. What does microphone delay duration mean? Hey. Yo, what's up? Oh, I get it. So, like, if I, like, stop talking, then he'll, like, pause before he moves over. Alright. Now what we're gonna do... we're gonna do a window capture. Okay, do you see what I mean? So now all we have to do is have to chroma out the green. Okay, not this one, not the default one. Let's see. Chroma key. There we go. You see, it knows exactly what I want. Do custom color. I'll just... let me fit this one. Okay, so what I'll do is I'll select this one. Even though I think it is, yeah, the exact same. So, no point, but that's okay. Boom. Yeah, I'm back, baby. Okay. So, now what I'm going to do with this one, we're going to crop as close as we can. Right? Boom, 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 boom. Yeah. I'm going to flip this picture too. I don't care that my stuff will be on backwards. It's not a huge deal. So we will flip horizontally. Yeah. Okay. Oh, this is a lot more comfortable for me right now. Okay. So, it might be a little awkward, because, you know, some people don't play Roblox, and this is very Robloxian, but, you know, yeah. Okay, I'm just testing its pickup. Alright, let's continue. I could be lying on the floor for all you guys know. I'm not, but I could be. So let's do the derivatives. Not 6. Actually, we did this one already, and we know the answer. Because it was a stupid mistake. I'll take the derivative real quick. Okay, you plug in 3, this is going to be 6 minus 8, negative 2. So, even though our velocity is... oh, shoot, that's pretty negative. Okay. 9 minus... let's see, 9 plus 16 is 25 minus 24, so it's at 1. So we're actually slowing down. You can write it out, I think, the way she had us do it, my math teacher. Well, everything was just... oh, everything was just ripped. So many Among Us is on my paper. You can write this out with a table. Or no picket fence table yet. Okay, that might be next year, actually. Oh, but we learned L'Hopital's rule this time. Has something to do with the indeterminate form. It's delicious. Okay. So we're just figuring out velocity. So we just need to do... it's going to be 18. So we're moving to the right. Okay. I'm not going to write it again. Because I don't... well, actually... you can just tell by the degree of the function. There's no acceleration. Which means it's moving at a constant velocity of 7. It makes sense if you think about it. Like, function. function-wise, because it was a linear function, right? So it's always going to have a constant slope. Therefore, its velocity is going to be constant. And since the velocity is constant, there is no change in velocity. So the acceleration is 0. Hold on. Oh, it still keys out the rest of that green stuff. Interesting. And then look at this. Alright, keys on my eyes too. Hey, not cool, man. Don't do that. But no. Hey guys, what's going on? Yo, what's up? Yeah, so the other day I was just doing stuff. Yeah. Okay, just know the threshold, you know. Just experimenting. I think this is better than a VTuber model, because you don't need to have a camera constantly pointing at you, you know? No, I don't want it. Okay, well. Let's see. It's going to be negative pi over 2 cosine right. And we're going to plug in 9, so negative pi over 2 times cosine pi over 4. Cosine pi over 4, that's going to be negative pi over 2 times root 2 over 2 negative pi root 2 over 4. Let's think about what this could be. I'm guessing, since it's, I'm thinking it's this actually. Yeah, just by, you know, shoot, just by estimating. Kinetter? I low-key don't know. I'm gonna test something. Hold on. Ah, it's me. Ah. Yeah, and now I'm gone, but now I'm back, and now I'm gone, and now I'm back. Whoa. Oh, he jumps every time I like clap my hands. You can just assume. And you just need to know. You know, you don't actually have to solve it. You could. It would help your work. You know, you could double check your work. Hold on. I want to make it so he's not static. What does pixel mean? It's too smooth, I guess. Well, I guess I control him here. Oh, you can do it here. Okay, so closed mouth. Oh, and then he lights up. I see. Yo. Well, that adds a little bit of life. Maybe I'll keep this little jump at the end. This is, I don't like this one. But it's a cool thought. This one's a little goofy. See? I kind of like the breathing one. You know, I think it just looks better. So we'll have some static motion with it too. I think the darken also helps. You know, when I actually do talk. It picks up the crunching. This is going to be an annoying derivative. If you need help following along, no you don't, you got this. It's, let's say, approximately that. So, kaboom, kapow, kaboom, kapow. Rest in peace, my granny. She got hit by a bazooka. Yeah, I think about it every time I hit the hookah. Kaboom. I chose the wrong one, minutes per liter. Never sing to yourself in the middle of an exam. It'll distract you. Trust. Ran out of breath there. Excuse me. Oh, this is so much harder. Why would you... Okay. I think it's gonna be positive. I'm not gonna gamble that though. I was gonna guess this. Dollars per kilogram, not kilograms per dollar. Make sure you got your facts straight. Nom 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 nom. What does global mean? Soldier boy. Okay, this would have been more intimidating if we hadn't just done it. This feels different than when I remember this version of the song. Shoot. I hate relational rates. I think I know what we have to do. Okay, so what we know, I was doing the thing again, hold on. Okay, so, government, whatever. We know dH, dt, is the change of height, equals 2 meters per second. We know ds dt equals 5 meters per second. And what we're looking for is the volume of this prism, square prism. Or we're actually looking for the rate of change. So we know we know the volume is, it's going to be side times height. Right, now if we take the derivative of that, we're going to get equals s dh dt plus h ds dt. And we're given a point in time, right? Or we're given the values. So we know we can just plug this in and we're looking at the rate of change. So equals let's just plug in these values. So it's going to be 6 and 2 plus 7, 5. So this equals 12 plus 35, which equals 47. So we're not given this in the problem. Did we even have to solve it? That would be really funny if also, this is wrong. This is negative. So it would actually be 23. So, oops, that's my bad. Gosh, we didn't even have to solve it. Okay, the base. Wouldn't it be kilometers per second squared? Oh, that's not a square. I get it. Yeah, but it's still the derivative. Interesting. Oh, we're I get it. This is what we call learning. Okay, I'll finish this one up, and then I'm gonna take a quick break. I promise it'll be quick this time. What? But at time 0, at a certain instant. Well, then would it be the derivative, wouldn't it? What is he playing?
I do videos and I use a keyboard all the time, 24.
It's a Peter Knetter video. I used to watch him all the time. I should really get back into him. Testing the acoustics of this thing. I need to brush my teeth. I've heard mics, like if you don't brush your teeth, they can stink. I don't know how true that is. Bazinga.
Here we go, off the rails. Did you know it's time to raise our
Okay, I will return momentarily. I forgot I have to give a reason now.
I'll be there in a flash. You could say my hat is off to you. Oh, we can zoom all the way to the moon from this great wide wacky world. Jump with me, grab coins with me, oh yeah.
pull this thing up. Alignment center.
Jump up, don't be scared. Jump up and your cares will soar away.
Oh, what the?
And if the dark clouds start to swirl,
Yeah, we'll just. Hold on. I'll figure this out before I leave.
so let's all jump up super high up in the sky. There's no power up like dancing. You know that you're my superstar. No one else
I'll be back.
is fun. I'm flipping the switch. Get ready for this. So let's do the Odyssey. Odyssey, yes, see. 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 Odyssey, Odyssey. Spin the wheel, take a chance. Every journey starts a new romance. A new world's calling out to you. Take a turn off the path. Find a new addition to the cast. You know that any captain needs a crew. Take it in stride as you move side to side. They're just different points of view. Jump with me, grab coins with me, oh yeah. Come on and jump up in the air. Jump without a care. Jump up 'cause you know that I'll be there. And if you find you're short on joy, don't fret, just don't forget that you're still a one-up boy. So go on, straighten up your cap. Let your toes begin to tap. This rhythm is a power shoe. Don't forget you're the superstar. No one else can make it this far. Better go through that stash. Now you've got panache. Oh, let's do the Odyssey. It's time to jump up in the air. Jump up, don't be scared. Jump up and your cares will soar away. And if the dark clouds start to swirl, don't fear, don't shed a tear, 'cause I'll be your one-up girl. Now listen, all you boys and girls all around the world, don't be afraid to get up and move. You know that we're all superstars. We're the ones who made it this far.
See, I told you it'd be shorter this time. Are those hiccups? I'm super. You know what? I don't even know what's going on. Alright, we're just. Here, let me situate myself, and then we're just gonna do some math. Okie dokie. Let us get. Actually, hold on. I got a grand idea. I'm gonna try this out. Nice. Okay. You should be able to hear me the same. I've just moved some stuff around. Specifically, I've moved myself around into. We'll just call it a lazy position because that's what this is. All right. Let's see. It was given this problem. What equation should I use? So instance the top line. I think it's this. I think? No. Okay, so I just don't know. Let's figure out why. Is we serious right now? Okay. Let me not forget the area of a circle. Opposite over adjacent. So I guess this one's just recognizing your geometric stuff. Right. Distance. Thinking real hard right now. Just be this, yes. Okay, sweet. Next one. Okay, I'm gonna make one change to this setup. Okay. This is easier for me to see. You can't see it, but I can. Okay. Let's see. Nope, just there we go. Okay, see? So we derive it in terms of y. Right. It's more like dt, this sort of thing here. So now we can just plug in, or no, this is still not clear. So we'll just plug this in, so it's 4, so it's negative 8 plus 8 equals 0. I guess it's 3y minus. After multiplied at 8, I would use 3y minus 2 and y minus 1. Actually, we just need to plug it in here. So, I think that should be y squared, right? Yeah, I don't know why it's scooched over. But it would be 12 plus 12 plus 8. So that equals 32. Uh-oh. Should be a fraction. Okay, hold on. See if I did this right. Oh, because we're deriving in respect to t, not x or y. Okay. Okay, actually, what I'm gonna do. Alright. So I think that's working out. USB receivers are ready to go. Okie dokie. Let's see. X over 9. X over Y equals 9. Okay. Now that we know what we're doing, this shouldn't be too difficult. We try not to break everything I own. Let's see here. So we can. Let's just do it like that. Okay. So it's going to be. We can multiply. Actually, no, we can't. We need to isolate this. But let's plug in what we know so far. So we know that okay, and then that simplifies to, let's see, y dx dt plus 2 over y squared. Okay, I think this one's going to get a little complicated. So y equals x over 9, right? So we have, and then x equals 3. So I guess y can equal 1/3. So now we'll have 1/3. Since we're dividing it by 1/9, it actually just, we can multiply by 9. So this will just become 3 dx dt plus 18 equals 0. So I think the answer is -6. Oh, that's cool. Ooh, I've never seen that feature before. And we got it right too. Double bonus. So it equals -1/2. Where did you get that? There we go. That doesn't look like a 1. Okay, well, no, you know what? Here. -1/2. No. There we go. Wasn't even the right answer. That's a 7. It looks like a 2. Be negative 7 over 12. That's a 3. Now we need to find what x equals. X equals 2. So this will be 6. Plus 2 dy dt equals 7. So subtract that over. So it's going to be 1/2, I'm pretty sure. I hope it's right. What? Why did I think 7 was on the other side? It's derived. Goodness. Maybe I'll get back to sitting up. So cosine pi. If it isn't, I'm setting up. Alright, we're sitting up. Clearly, but unfortunately, this setup isn't working for my productivity. son. Have a bump. The balls. Okay. What I actually might do, since I'm getting a little tired, I might just take out some real paper. Or, I might draw on my iPad. Actually, I have an idea. I'm gonna try something real quick. So we're gonna hide the display capture real quick. There used to be a free OBS plugin where you could like make text do cool things, but then he put it behind a paywall. So we upset now. Hold on, my app's bugging out. Give me a second. Let's see. Yeah, because it's on jeans. If I test it, let's see here. Okay, it's a little laggy, but okay, it just rarely updates, I guess. Let me think of solutions. Hold on. I think this is the best. I think this is the best we're gonna get. Okay. Okay. So here you'll see, like if I write, it'll lag a little bit, but you can see my work, and I'm doing it on my iPad. It's gonna be a whole lot easier that way. See the work come up. And we're gonna try. Supposedly this feels like paper. And it does. Isn't that nice? Let's see here. And we're at y equals 6. I don't know why it's bugging out. Whatever. Okay, so y equals 6. So 2, 6, y dt equals 7, -3. So we have dy dt equals -21 over 12 equals -7 over 4. Let's try that. Yeah, okay. Okay. So now we have x, y equals 4, right? Because that, now we're going to derive, we have to use the product rule. So x dy dt plus y dx. I wonder if it's like a low battery or something. Well, this pencil is tripping. Where? Maybe it's a spotty connection too. It could be that as well. I wouldn't be surprised. So we have x times 1 plus 0.5 dx dt. See? Like those weird jump things. I don't know. I would charge it too, but I'm charging my iPad right now. Maybe I'll... hold on. might look into that later. Let's see here. So now we'll solve for x real quick. So xy. So it's just really weird, I guess, overall. Maybe I'll look at replacing the tip. I'll do it when I actually figure out how to. So, you know, xy equals 4, right? And since y equals 1, then x must equal 4. Oh my goodness. X must equal. Yeah, so therefore we have 4. Let's actually say 0.5 dx dt equals -4. So if you divide that, then you have -8. Pretend that says -8. No. Oh, because the derivative. Okay, I just looked at the wrong number. Getting a little tired here with these technological shenanigans. What if I just... Okay. Trying to make this like a positive viewing experience, but also convenient for me because I'm doing math, right? Okay, let's see if I close that. Maybe it's just Microsoft. Let me try something here. If this works, I'm gonna lose it. But I can give it a shot. I don't have any other counts on here. Okay. See, because if I do it with a stylus. Yeah, if I do it with a finger, it's no problem. But then if I do it with this pencil... It's like as if I have to write like up, down. Okay, I'm gonna have to talk to someone about that. But we'll figure that out later. I'm not sure if this is sticky or if it's magnets. Okay, hold on. Let's try something. Okay, we're gonna look that up real quick. No. Oh. Who would have thunk? It's a screw. Maybe this one will do better. No, that's okay. I just need you to... Okay, so this is just dumb. That's all. I have a really old one in here. I'm gonna try that real quick, just for, you know, sake of trying stuff. And try to make sure nothing goes down bad. We'll probably have to charge it though. Okay, unfortunately, for now, we'll just have to keep doing the same way, which isn't a huge issue with me. As a matter of fact, we can just keep doing things the same way we've been doing. This is the way I'll split it. Oh, how funny. It's mocking me. Yeah, see, this is a cry for help. This was me practicing crossover, because I missed that lesson. Alright, so what we're gonna do is we're just gonna do our work here. I grabbed the wrong stylus. Just gonna do our work here. Alright, so just 3 more. I love this one. Menu theme. Oh great. Okay, hold on. I'm gonna try. wonder. Okay, hold on. Tuna settings. Oh, okay, I know that. I get it. At least you should be able to do this one. Try these. I'm gonna stop tuna. I'm gonna start it again. Okay, so I just don't know. Negative, or not yet actually. Well, it would be negative 25 over 2. Okay, there's hope yet. Okay, so they gave us a domain. I'm gonna write that down because you can see it right there. Yeah, see now the Control Z works. And it doesn't interrupt actions here. Should have always just been using a whiteboard. So let's see. So 5 cosine x minus, let's see, sine of pi over 4, 2 over 2 dy dt equals 0. We can rewrite it like this. We'll solve for x real quick. So if this is y, Okay. I'm trying to think. So that would be 2 root 2 over 2, right? Minus root 2 over 2. So is root 2 over 2. So x also equals pi over 4. So pi over 4 is going to be 5 times 2 times root 2 over 2 divided by root 2. So this seems far-fetched, but it was right. Okay. Don't doubt yourself always. Doubt yourself sometimes. It's always good to keep yourself in check. Okay. Charles Martinet in the recording theater, just humming. Hold on, I'm checking something. Big junglers, big junglers, big junglers. I'm sorry, that was so unfunny. Oh, what the? Sweet, yes. Big junglers, big junglers, big junglers, big junglers. You know, I will never forgive Nintendo for canning Tomodachi Life. I loved Tomodachi Life. That was like my thing. Sorry, Mitomo. I love Mitomo. Cosine pi and negative pi is the same thing. Oh, no, actually. There. Okay. We're making progress. We're coming out of our sloth. You know, feeling very unencouraged, very lazy, but now we're getting back into it. Okay. So let's say the radius equals -2, right? You can say 0, but h equals 9. And r at some time equals 13. I've never written it like that before. So we're solving for that. We know volume, so the volume of a cone I think it's... Let me double check. It is, okay. Alright, and then so from here, we'll take the derivative to find it, right? So pretend these two, because they're both constants, right? And actually, what we have to do, so you can take these out beforehand, we'll do... Okay, wait, hold on. So if we do it this way, we actually need to... Let's set this up correctly. We'll take out the constants. And then it will be... Right? So this is the formula. Now what we can do is we can start plugging in values. So... R squared, 169 times 0 plus 9 times 2 times 13 times -2. Which makes sense. Our value should be decreasing since one of our values is staying the same and the other is not moving at all. So this will be... See, this is going to be -36 times 13. I'm going to trust that... Okay, there are two big numbers here. The answer I just got is none of the numbers. Oh, because then we have to divide it by 3. So 468 divided by 3. 156. Boom. Okay, so related rates isn't that hard. There's this trough one that we infamously spent a long time doing in class, and that one was tough. If you don't know what a trough is, it's what like pigs eat out of. No political jokes to be made there. Those bananas are really good. Let's make it clear. I think I'm in the habit of writing units because I don't know if it was actually on the test. I don't remember exactly what was on the AP test, but there was a trick question on one of the quizzes where the units changed, so you also had to convert the units. Volume of a sphere. I got it right. Let's go. Okay, so now we're going to take the derivative, right? Which simplifies just. And then so we'll plug in the values we know. Right, we'll simplify this a little bit. I think it's 289 if I remember correctly. Yeah, 289. So we multiply that by 2, we're gonna get 578 pi. Boom! Shakalaka. Alright. So, radius of a sphere is decreasing. I'm gonna skip the units this time. I'm just gonna read. 1, so at a certain instance, radius is 4. You know what I really want? I got a lot of stuff on my wish list, right? But obviously, I can't have all of it. For example, this game's never coming out, unfortunately, I guess. Then we have, what do you call it? Rocket League. I just kind of put this here as a joke, because, you know, it's free on Epic Games, but not on Steam. Papers, Please. I had it at one point, refunded it, don't know why. It's really fun. I kind of want Replicube. I really, really want Tetris Effect or Puyo Puyo Tetris. I could probably do fine without Puyo Puyo Tetris. I want to play Tetris. I love Tetris. That's like my thing. I'm a basic player though. I don't do any of those like T-spins and stuff. I could practice, but not, you know, I don't really want to. You know what I mean? Okay, volume of the sphere again. So, just remember the derived formula. Right? Alright. Let's see if we can just do this on half a page. Okay, so let's say the site length equals that, and then at some point, I just have to do that. I have to write as a function. 22. So we're looking for the area of a square. So the area of a square equals this, right? And the derivative of that would be, this is how you get the rate of change. So this, 2 times 22 times 15. So this is going to equal 30 times 22, which equals, let's see, 660. Nice. Okay, I'm gonna take a break. I'll be right back. Alright, let's get back into mathing it. Oy, oy. Something stinks up here. Multiple rates? What does that mean? Okay, the volume of a cone. So the volume of a cone is that. I'll just do the derivation in my head. Or actually, I need to write it down anyway. It doesn't matter. Right, so now we'll just plug in our values. R squared, so we have 9, negative 4, plus 10, 2 times 8 times 3. So this equals pi over 3, negative 36 plus 480, so pi over 3 times 400. Yeah, okay. 44. I think that's an answer. No, okay, let's figure this out. Because I squared the wrong number, that's why. Alright. 64. There we go. 10, 2, 8, 3. So this is actually going to be negative 256 plus, it's still 480, so pi over 3, 0 minus 256, can't do this in my head, 224, okay, that is an answer. Is it positive or negative? It's positive. There we go. Okay, let's see here. Okay, so side equals 6. The height is negative 1. At some point it was 3, and at the same point this was 9. So it's a pyramid. I think it's the same as a cone, but it's a square instead, right? Oh, it's right there. Yeah, okay. Let me not get that confused. Right. Okay. So then we'll plug in our values. 9, 1 plus 2, 3, 9, 6. So this equals 1/3. 9 plus 6, 6, 9. 36 times 9 equals 4, 5. Yeah, that looks about right. So then what we do, it's going to be 300. What do you know? 333 over 3, which is 111. There. Okay, maybe not. Let's see. It appears I've also failed to account the negative right there. Oops. Okay. Okay. I'm not sure. Hold on. Let's see. Okay. Okay, there we go. Is it 1 L or 2 L's? I don't know. I don't know how to do cursive. Okay, it's a square prism. What is a square prism? A cube? Do you mean like a rectangular prism? What? Who calls it that? No one calls it that. We're looking for the change in surface area. It gives us the formula, so I'm not going to bother deriving it on my, or figuring it out on my own. Okay. I can make a guesstimate already what this is going to be. No, I can't. What? The song means they're hungry. Oh, because I multiply this wrong. Right. That's negative 23 times 4. There we go. Alright, now we get our bonus question. This is a song when they're sleeping, and you can view their dream. Thank you, because I didn't want to derive that. It's gonna be long. All right, let's see. There we go. All right. More related rates. Let's see. 25-meter ladder. Okay, so here's what we know. We're trying to solve for this. We know this is. So let's see. Let's call this the side. We can call this. Well, this is the hypotenuse. We'll just call it the diagonal. So we know, let's say the diagonal equals the height squared plus the side squared. So if we derive this in terms of time, and we already know these values. The height at some point equals 7. And then from there we can figure out, right? So 425, that's 25 times 25. We can double check. 525. $525 minus 49 equals 400. Let's see, 76, I think. Yeah. Now what's the square root of this? Well, let's just, for now, we're just gonna say that the side at some point was 476. Let's see. Let's try 24 squared. 22. Oh, well, I don't think it has a perfect square then. Yeah. So we'll plug these values in. 25 squared. The height at some point was 7. And we're solving for dH dt plus 2. I'm going to double check this math. 25 squared minus 7 squared. Okay, so I'm just double wrong. Alright. 576. 24 squared, 576. Okay. See, this wouldn't happen if you knew your Pythagorean triangles, which I don't. And we know the change is 3.5. So now we can solve. Calc, he's cheating. Okay, you know what? You know what, Juko? I'm not having it. All right, I'm not today. Not today, buddy. I'm allowed a calculator. It says right there. Now, if you're saying, where is it? It doesn't say anywhere. Well, there's the show calculator button right here. I just happen to be using a smarter one. Okay, we'll simplify this. So it'll be, I'll just do it now. -12. Boom. Okie dokie. Oof. Not the 7 thumbs downs. Oof. I don't think I can go on. Okay. We'll still call this the diagonal. We'll say this is, again, the height, and that this is the side. Okie dokie. So let's see here. Alright, same formula as always. dH dt plus 2s ds dt. Right. Now we'll plug in our known values. We can find, so we'll do 15. That's not 15. How about you don't spoil the problem for me? Okie dokie. No spoiling. Let me solve it. This is gonna be. I do know this one. This one is 225 plus 400. I know that more confidently. 625. So that equals 25. All right. So our D, our diagonal at some point equal 25. So here 25, and we're solving for this equals 220. 8 plus 2. What's our S? 215. 5. Yeah. So it'll be 50 dt equals 320 plus 150. So then this goes to, we'll just simplify it here, 470 divided by 50. So 47 divided by 5. Which, what do you know? It's 9.4. Wow. No, it was D. You were correct. Congratulations. You must be super proud of yourself. You were tricking me? Really getting my head there. Grr. I'm getting tired of these triangle problems. Let's see. Okay. What? Package was delayed for our light switches. Let's see. So someone's standing here. So side is 10, right? Our ds dt equals 0 because he's just standing here, right? And then so this. I believe it's decreased since we're going up. from the north, so actually it would look like this. Because he's coming down. And we're solving again for this. And at some point, this was 24. So now if we solve for our distance, this one must be A. I don't know. That's a funny square root. Okay, I was about to say 13. It's not 13. I want to say it's 26. Oh, I knew it. Okay. So, at some time, our distance was 26. So, you know the formula. And since this is 0, we can ignore this one. So here, let's simplify. Let's make this easier for ourselves. No way I could simplify to that. I'm guessing this number, but let's check. Yeah. It was actually B. You're wrong. You're wrong, Jugo. You're wrong. Whoa. Misinput. I hate to tell you, but the B and A are nowhere close to each other on the keyboard. You use different fingers to type those two letters. Are you sure about that? You sure? I'm taking a look right now. You send me a picture where they're right next to each other, and then maybe I can get you some grace. I don't have ownership to a picture. So maybe you're lying is what I'm hearing. Maybe you're lying. This is manifest. I'm pretty sure that's 16. We're just gonna go all in. Not before double checking our answer. It is 16. All right. So you know the formula already. Thumbs down me all you want. You'll know deep down what the true answer is. Actually, we can ignore this first term. We know that equals this. And we're looking for this. So we can rewrite this as goodness. Actually, it would be positive. You'll see why. Okay, we can can divide it by 8. Divided by 4. Big ol' juicy 6. Kerblam. Answer was D. You're wrong. Was it? Yeah, answer was D. Huh. Alright. More. C and D. Okay. Okay. That time you're right. But the other time you're wrong. So I'll give you 50% on this one, alright? Volume of cylinder is increasing. The volume at some point was 80. And the height. So but now here's the issue. The surface area what? I have to go back to work. Okie dokie. Bye bye. You want it's B? No, I don't think it is. Well, we'll see if you're right. I'll let you know if you're right, okay? Let's get straight into it. How do we get rid of those? Let me check my notes. I think we probably did something similar to this. How did I come up with that? I'm gonna have to get creative with this one. Let's see. I really don't know. Okay, let's think. You didn't see that. I didn't do any goofing off. Let's see, can we solve? So r equals 4. Right? At this certain point of time. Now we can solve for this using the same equation because let's see. So let's see, so R equals equals 4/5 of H, right? And so we'll use this here. Actually, we don't want to do that. We want to do it the other way around. H equals 5/4 of R. So we'll plug that in here. So it'll be V equals pi R squared times 5/4 R, aka V equals 5/4 pi R cubed. And we can solve because we know all these values. Okay, I'm just gonna simplify this real quick. It'll be 60 pi, because this is gonna be 16, 4, 5, you know, yeah. So this equals 1/6. After simplification, important thing about math is thinking out of the box. A lot of thinking for me, I guess. Let's see. So now we can plug it into this formula. Okay, let's see if I can do this. R is 4. This is 1/6 plus 2 pi. I don't think H is changing at all, right? Yeah, height is constant. Plus, so let's see, plus 5 times, oh, we know it's 1/6. Okay, let's simplify. So this equals divided by 2, 8/3 pi plus, this is going to be 5/6, so plus 10 pi over 6. So for now, we'll just keep this in its unsimplified form. You know, we could have simplified that, but whatever. I know this is it for a fact, so this equals 26 pi over 6. aka 13 pi over 3. Shoot! Okay, let's see, maybe there's something I missed here. Gosh darn. 1/4. $16. Yeah. 5 times 4 is 60. Let's see. Did I forget about H? It appears I forgot about H. Okay, that would explain it. Alright, I will be momentarily back. BRB.
Gonna start.
What's up? We're back to do some mathematics. Apologies, I had stuff I had to go do, you know. Duty calls. Okay, I hate hearing my own jokes. I'm turning that down. Alright, let's begin. Let's just say so we're looking for this of a cube, which is going to be but what can we get from this? We know that the surface area of a cube equals this. So we'll solve for S. So at some point we know the surface area was this. So we'll divide by 6. So we get, so S equals 2, right? And then now we're looking for the change in S. So we'll take the derivative of this. So A prime equals 12S ds dt. Now we can plug in our known values to get an answer that ds dt equals, let's see, to equal this, right? So then now what we can plug in are our numbers. So we get this, 15 over 4. You have got to be kidding me. Oh, that should have been squared. So this should have been 4. So, oops. Okay. Let's try not to make these silly mistakes again. I really just want to be done. So let's go. Let's proceed. So the perimeter is increasing by 5. At some point, the perimeter was 30. And now we're looking for the change in area of the square. So that would be this. But we know perimeter, since it's a square, equals this. And since it was 30, we know that S has to equal 15. Now we'll find the derivative. Right, and so we know this was 5 over 2. So we know the change equals 5 over 2. Right? Yeah. Okay. So now we'll plug it in here. So 75. What is going on? I can't be that bad at fractions, right? don't understand what went wrong. Let's see. This touch button is going to be the bane of my existence. But I low-key don't know. I'm gonna say this, and we're gonna see why. 15/2? You wanna explain that? Oh. Goodness. Dumb little mistakes. See if we can get one flawless. The circumference. So we know the circumference of a circle equals 2 pi r, and then so the derivative of that would just be 2 pi dr dt. So this is the rate of change. We need to figure out r though. So we know the area of a circle equals pi r squared. So I'll put 36 equals pi r squared, 36 pi. These cancel out, so r equals 6, right? So now we'll take the derivative of this. And we'll plug this in, so 8 pi equals 2 pi r, or 2 pi 6 dr dt. We can simplify, get this out, this becomes, it'll be 2/3. For pi/3. That's finally an answer this time. Alright. Let's see what else we got going on here. Let's see, so volume is increasing by 25 pi. And at some point, the volume was 32 pi/3. And we're looking for the surface area of a sphere. Let's think, why would this be? So we have the area of a circle, right? Then how come if we only multiply it by 4 that it becomes? Let's look it up. I'm curious. Okay, let's see. Oh, I hated this. Ugh. Okay. I want to see the cucumber slice. What? Okay, this proof stuff is... I'll do it in college. Okay. So this equals... It's going to equal 8 pi r dr dt. Now we need to solve. We know the volume of a sphere, right? It's going to equal 3 pi r cubed. We can plug this in. And we'll simplify. R equals 2, right? So now we'll derive this equation. So we're going to get this equals 4 pi r squared dr dt. And we'll plug in 2 and this. So 25 pi equals 4 pi 4 dr dt. So then this becomes, it's going to be 25 over 16 equals dr dt. So from here, it's going to be 8 pi times 2 times 25 over 16. This will be 1, this will be 2, so these will cancel out, so answer is 25 pi. Boom. Okay, we're getting close to the end. Let's see.
It's me, Mario.
Okay, we're getting really close. What is this? Minecraft. Getting friggin' tired. You know? Okay, it's gonna be 11. Alright, so it's gonna be 12. What is this? Linear approximations. Lx equals f prime of c, so the slope at c, x minus c, your x coordinate, plus the y value of that function, or the value of that function. So according to this, it's, so you would write, like, for example, f of a is approximately L of a, which equals f prime of a, x minus a, plus f of a. Does that make sense? What is this song? So goofy. Not to be sleepy right now. Actually, no, it gets pretty fire after this. Let's see. Okay, so basically you would write this out. So our function, so in this case, let's say g of -1 would approximately equal to L of -1, which equals 2x plus 1 plus 5, right? And then so now, so this is like our approximation. This looks about right. So then g of -0.9 is approximately equal to L of -0.9, which equals 2 -0.9 plus 1 plus 5. So then we're given, this will go down to 2 times 0.1 plus 5, which equals 5.2. Oh goodness. Oh, that's hold on. Let's take a look at that again. Okay, so that's the pattern we've been moving down, I guess. This looks about right. Not that it really matters. Okay. I can do this one in my head. Negative 14. Negative 17. Okay. So let's not forget the formula. F of A will approximately be L of A, which equals F prime of A times X minus A plus F of A. You should actually use a different value here. So let's say because otherwise see f of a, then we use it twice, and then so you can't add a function to itself contained within another function. So let's say that basically. So in this case, will approximately equal L of A, which equals, the derivative of this would be 5 x minus 7 plus minus 2. So now we'll approximate 6.9 is approximately equal to L of 6.9, which equals 5, 6.9 minus 7 minus 2, which then equals 5, 0, negative 0.1 minus 2. So this equals negative 0.5 minus 2, which equals negative 2.5. There. Alright. L'Hopital's rule. Here we go. It's not El Hospital. L'Hospital. It's the L'Hospital. L'Hospital. Okay. So basically, what his rule states. So let's see. If you have this and you plug the limit, okay, I know what I'm thinking of, so let me just take a look real quick. Okay, so let's say we have this. Let's assign these. Let's say this is f of x, and that this is g of x. So if the limit, as x approaches whatever value it is, in this case c, of f of x equals 0, and the limit as x approaches c of g of x equals 0, then you can apply L'Hopital's rule. And this also works for if both of these are like infinity, or if it's like negative infinity. And then it says one-sided limits. I forget what one-sided limits are. I'm sure those will come up eventually. So let's not worry about that right now. But first let's check. So the limit as x approaches 1 for x e to the x minus, is that a e? E So this does equal 0. And now the limit as x approaches 1 for x squared minus 1, which also equals 0. Therefore, so then you would write by L'Hopital's rule, then you can say the limit as x approaches 1 of x e to the x minus e over x squared minus 1. This equals the limit as x approaches 1 of, let's see if we take the derivative here, it'll be, let's see, x e to the x plus just e to the x. And then you would chain rule this technically, but when you take out the the derivative of x is 1, so you don't have to worry about that. And then 2x. So now you can plug in 1. So the limit x approaches 1 equals, let's just say equals down here. As you can see, it'll be 2e. It'll just be e over x, e. Because then you plug in 1, it'll be 2e over 2. So it'll just be e. Alright, I don't need to explain it again this time. We'll just assign, so we'll just check first. If the lim as x approaches 0, e to the x minus 1 does equal 0, because anything to the 0th power equals 1, except 0, that's a funny thing. Now the limit as x approaches 0 for 2x also does equal 0. So therefore, by L'Hopital's rule, we can say that the limit as x approaches 0 of e to the x minus 1 over 2x equals the limit of e to the x over 2 as x approaches 0. And then so this just equals 1/2. Okay, so limit as x approaches 1 of x, l, and x. So note that this is basically log base e of x. And then so if x is 1, so if it's log base e of 1 equals what, right? So think of it like this. E to the what equals 1, e to the 0. So this equals 0. And then no matter what, it just equals 0. And now lim as x approaches 1 for x squared minus 1 also equals 0. Therefore, by L'Hopital's rule, you don't have to write that every time. It's more of an FRQ thing. But I just do it on my work anyway. I don't know. They don't check your work. They don't check your like written work on any of the exams, I don't think, except physics. But usually, because you usually be given a scratch piece of paper. FRQs, they check your work. No, I should say on the multiple choice, they don't check your work. They just check if you've got the right answer or not. It's the FRQs where you need to show your work, you know? Okay, so by L'Hopital's rule, hold on, watch this. This is really cool for the pen. I can detect when I'm pushing harder. So we'll say the limit of x, l, and x over x squared minus 1 as x approaches 1 is equal to the limit as x approaches 1 of, this will be ln x plus, it'll be x times 1 over x, so plus 1, over 2x. Now you plug in 1, right? And then so it'll just be 1 over 2 again. So 3 pi over 2. Well, any multiple of, well, actually pi over 2 and then every pi after cosine, since it's x, will be 0. So this is also 0. By L'Hopital's rule, the limit as x approaches 3 of 9 minus x squared over cosine pi over 2x equals negative 2x, or the limit as x approaches 3 of negative 2x over negative pi over 2 sine pi over 2x. And then then we'll solve this one. If we plug in 3, it'll be negative 6 over, actually we'll write it like this. It'll be negative 12 over, it'll be 12 over pi, or just simplifying this first. And then, let's see, negative pi. Okay, one more. As x approaches infinity. Now, this one is the same. You approach it the same way as x approaches infinity. For x squared minus 7x. What's going to happen? It's going to go to infinity. So now what you check is that, are they both going to go to infinity? Like, is one going to go to negative infinity? Will one not go to infinity at all? That sort of thing. So just think of it, the function's going to increase to infinity, and it makes sense. So then you're going to say again, by L'Hopital's rule, the limit as x approaches infinity of the following function equals the limit as x approaches infinity of these two individual functions. So it would be 2 ln x, right, times 1 over x. So then it would be 0. You can already see it, right? Because actually, I think it would be infinity. Because let's simplify this further. Let's multiply both sides by x. Actually, now that's a greater question. Which grows faster? X squared or the natural log? I'm inclined to say x squared, and I was right. Let's double check. Oh, that would be an easier way to write that too. Technically this works, but it's actually, you get the same answer regardless. No, you don't. These are two different answers. Let's see where we went wrong here. Notice we have an extra natural log here. Let's not forget exponential rules or logarithmic rules. It'll probably be very helpful for, placement test stuff to see if you know the basics. Okay, same thing here. So the limit as x approaches infinity from negative 3 squared plus 2x. This is going to equal, you'll see, right? It'll equal negative infinity. And now the limit as x approaches infinity for 4x plus 8 equals infinity. Hold on. If I had the option, I would say this is undeterminable. Because it's infinity. Well, that's pause. Because then it would. I don't know. Okay, I'll look at the explanation, but for now we're just gonna skip to the good stuff. All right. And then if we go to infinity, it goes to. Oh, so even still, even if these aren't the same, we can still use L'Hopital's rule. Okay, that's good to know. Strange I don't remember us talking about that, but maybe not a very strong calculus concept, I guess. Okay, of 3 ln x equals infinity, yeah. As x approaches infinity, of ln of 4x is still going to go to infinity. So now the lim, as x approaches infinity, okay, by L rule, whatever, of 3 ln x over ln 4x equals 3 over x over 4 over 4x. Is that? No, but then every single time it would be just 1 over x. We'll just. Okay, and then we'll take a look. Let's see here. And why the freak did you move it up the front first? Hold on, I'm gonna go back and look at that old problem. Let's see here. Yeah, why can't I bring the 3 forward? You did that on a previous problem. Hold on. This doesn't make any sense. Why can't I bring this forward? So why are these different? Hold on. Oh, he doesn't. He does the rule twice. Okay. I think I'm starting to understand it better. Here, we need to finish this up anyway. We're getting close to 4 hours and I'm getting really sleepy. Let's assume this gets us an the indeterminate form. By rule, Hold on. Okay, no. So I was right, I just stopped working. Okay, and then we'll just simplify this of it'll be 2 over 2 or 1 over ln x, right? And then so this will be 0. Right, one more. Again, we're going to assume that this is indeterminate. It's just going to be infinity. You can see why, right? I hope so. Okay. Now a quiz. Oh, then our unit test. Oh my goodness. I'm gonna do this in my head real quick. Pi over 2, cosine's gonna be 0. That's gonna be 0. Alright. So. Pretend I did the whole spiel already. Alright, let f be a differentiable function. Alright, so let's write out our approximation. So f of a is approximately equal to L of a, which equals 7x plus 3. No, plus 0. It would be plus 0 if you really wanted, but we don't need to include that. You can write it like that. So negative 3.2 is approximately equal to L of negative 3.2, which equals 7 3.2 negative plus 3, which then equals 7 negative 0.2, so equals negative 1.4. Okay. Okay, top goes to infinity, bottom goes to infinity, so by L rule, that's just how I'm gonna write it right now. The limit, and then pretend I wrote all the stuff. You can see this goes to infinite, negative infinity. Let's see, how much more can I write just here? Okay, oh, I know this one. This could be negative 18, no, negative 17. How would you know that? You might ask. Well, it's because we already did that problem. Okay, both of these go to infinity regardless. Top one just goes to negative infinity. Yeah, no negative infinity, so by L rule again. They still both go to some kind of infinity, so then you would do it again. So then you'll see it just goes to 0. Alright, lesson 8 is just optional. This is a special case of L'Hôpital. When did you make this? Interesting. Nice. You know, think about it every now and then. It's incredible that Khan Academy is free. You know, with all of the services they provide. I need the song to change. Oh, we just did this one. If I remember correctly, I'm pretty sure. Let's see, we'll plug in 3, -6. Okay, let's see. -12 is going to be 12 pi times, let's see, -1. So what's this? We did something, it was a very similar problem. Oh, this one's conceptual, so we can just, let's see. So you're looking for the surface area. I don't know how this is the surface area. I tried to look up the proof earlier. But actually, okay, 2 cars are driving away. Let's see. So we'll say this is 1, and then this is 2, right? So the first car, they're driving away. This will be easier for me. Equals +3. So, and then at some point, and then we're looking for this change. So we know this was 7, this was, does that say, yeah, 3? And then so our diagonal, since I can't use hypotenuse, we already have an h. So it's going to be 21 + 9, or 49 + 9, 58. So this is going to be √58. So 2 times √58 times dd/dt equals 2 times 7 . Oh, this is actually, these numbers are wrong. This is the rate. I took the wrong number. So the number we should actually be using, so the first car is 5, the second car is 12. I believe this is 13. Let's double check. 25 plus 144 equals 169, which is 13. Yeah. So then now this is going to be 257 plus 2. This is 13. 212. I don't know anyone from there. It's a spam call. I'm just gonna let it go to voicemail. Okay, 3x squared dx dt minus 2y dy dt equals 0. So now we'll just plug in our values that we know. 3x squared 0.5 minus 2 negative 1 dy dt equals 0. Let's solve for x real quick. So if y equals negative 1, x cubed minus 1 equals 7 plus 1 plus 1, x equals 2. So now we're going to have 3, 4, 0.5 plus 2 dy dt equals 0. So here we'll have, it'll be, let's do 6 plus 2 dy dt equals 0. So negative 3. All right. Okay. You can tell already it's indeterminate form. I'm skipping all this stuff by rule, whatever, of 10x over 7 minus 8x. This still goes, so then you're going to do it one more time. And then, so this is the limit. Basically, this is another indeterminate form, and then so you can keep, so technically, as long as you have an indeterminate form of some kind, you can keep going. Side length of the side length, okay. So let's go. Negative 2, at some point, it was 9. So negative 36. Okay. Again, this is our linear approximation stuff. So f of a is approximately equal to L of x, which equals negative, since it's negative 1, x plus 6 plus 2, right? So we'll now put in our approximation, negative 6.2 is approximately equal to L of x, which is equal to negative 6.2 plus 6 plus 2, which equals negative 0.2 plus 2, which equals 2.2. All right. So instantaneous rate. So we just have to take the derivative. So this is kind of like psychology. It's like something about how you store certain. Memory was my worst unit, but I still did pretty good in psych, I have to say. I liked it, that's why. Okay, now let's plug in our number. So this equals negative 24. 1 minus 0.5 squared. So then this equals negative 24. Right, so negative 24 over 4. So minus 6 words per day. Okay, now. Okay, so we'll just take the derivative of this. Oh my goodness. Okay, and this is equal to this. So now we'll do it at 4. 1648 minus 24 minus 8. This equals 8. So actually no, this equals 16. Let me double check my math because I did something like this and I got it wrong last time. Okay, so if it's 4, 16, 32, 48, yes, minus 24, so that's going to be 24, and then minus 8 is 16, yeah. Okay, so this is 16, and let's see here. It's going to be 64 minus... It's actually, funnily, it's the same thing here. We just kind of move down the chain of command. So this will be 48 minus 32 plus 3. So this is going to be 16, negative 16, negative 13. Let's double check that math. Hold on. Okay, let's see. So it'll be, you could also think of it like it'll be 35 minus 48, which is negative 13. And since acceleration is positive, it's slowing down. Okay. So at this point, so after 5 seconds, since we're taking the derivation, acceleration. Okay, let's find these values. At some point, the radius was 5. The height is changing by negative 4. And we're solving for the change in volume. Alright, last one. Ooh. The surface of a cube is increasing at a rate of 15. At a certain, okay, wait, I actually have to write this one down. Okay, so the surface area of a cube is increasing by 15, right? And then at some point, that area was 24. So we're looking for the rate of change of the volume. Okay, so here's the volume. The volume, if you don't know, of a cube equals, it's going to be your sides cubed. Let's take this out, then, since we're just doing that. And so the derivative of that, based on with respect to time, would be this. Now we don't know any of these values, but we do have the area, the surface area, so we can solve for that. So we know the surface area of a cube is equal to 6s squared, right? Because this is the area of 1 square times 6 for 6 sides in the cube. And then so we'll plug in our known values. Divided by 6, so we get 4 equals s squared, aka s equals 2. Now we'll solve for the the derivative with respect to time by taking the derivative of our area equation, and we also have that here. So a prime equals, it's going to be 12s ds dt. Now we'll plug in our values. So 15 equals 12 2 ds dt. So this would be 15 24 equals ds dt. We can simplify this by dividing by 3, 5 over 8. All right, so now we'll plug in our values here. V prime equals 3 going to be 2 squared times 5 over 8. So this simplifies to 3 times 4 times 5 over 8. This becomes 2. We cancel this out. It's going to be 15 over 2. Boom. We are done. Unit 5, the mean value theorem. So this unit was about the applications of differentiation. And then now we're going into more, well, we're still doing that stuff, but now it's going to be analytical. So like, is a function increasing? We define concavity, aka the second derivative. So that will be, if not tomorrow, because tomorrow I have an event going on. But you know what I'm gonna do? Actually, I'm gonna take a break, but I'm gonna be back and we're just gonna chill. Okay, I would like to do some chilling. Okie dokie. Alright. What's up? We're back. Okay. I'm just gonna... Let's see. I'm gonna chillax for a little bit, and we are going to... hold on, just cleaning up. These pencils are weird. I don't know. Apple, it's probably Apple's fault, but yeah. Okay. So oh, actually, that's a lie. We finished Unit 4. We have a few more to go, but for right now, we're gonna chillax. Is this actually worth it? It looks fun, right? But also, I have like a billion of these on the 3DS, so I'm gonna put it down here actually. For El Futuro, I saw a horse magnet. What is? I don't even know what that means. I think I want it more. Yeah, we'll put it there. 5 laps at Freddy's. I didn't even know that was a thing. Let's say, done for today. Done for today. Done for today. Top day. Done for today. There. I've been playing this a lot on the DS recently. I'm not good at Puyo Puyo at all. I've tried. Not very good. But let's see, what do we got here? I want to play something chill. That's why I look for something. Marksman. Apparently I played a lot. I used to play TF2 a lot. I really hope I didn't use one of those achievement servers. Sounds really boring. Oh, that's funny. Wow, ESL. Good for you guys, I guess. Okay, wait, who are these people? Is that Conquest? Okay, well, we're just gonna do our thing. Alright. Last time I played... Oh, actually, let's finish FNAF World Refreshed. I'm getting really close. And I'm gonna transfer over my stuff because yeah, I'm gonna move it over because it's not like it runs slow. It's just it gets a little annoying every now and then, you know. Like, I'm not sure if you can hear, but my computer's going crazy right now because it's a dynamic fan, right? And so it adjusts based on, you know, the load. Okay, now. All right. Oh, so it just squishes. Yeah. Try to keep it as much of a regular ratio as I can. I just wanted to fill my screen. Sorry for the flashing lights. Also, I had to switch these two because something freaky happens if you have Freddy. If you're Golden Freddy and then you talk to Fredbear. Okay. This one's not timed. It's gonna sound a little annoying. Sorry. I think, yeah. I have a super. Okay, so we've changed up this game a little bit. Here, I'll turn this off when it's like not necessary, just to save your ears. I hope it doesn't despawn. We're not speed running or anything, so I don't need to worry too much about taking my time. Okay. Ouch. Ouch. Oh, can't go here yet. This will be later. I will never stop making spin-offs. I don't want to go too low. There's another cupcake up here. Yeah. Okay. I don't know if I'm gonna try to 100% the game, but you know, I might watch Astral Space video and figure out like, you know, the strat. Darn it. Oh, what? Oh, I also hate these floating bubble thingies. Because they're random, so they're a little unpredictable. Yeah, I'll kill this one. Because I can. Okay. Ooh, that one dropped 2. Okay, let's see. I don't think we need to double jump here. Or is this the way to... I think this is... Nope, there's a cupcake here. Right? I'm pretty sure this is the right way. Breakfast at Chica's. Romantic comedy. Killer with the heart of gold. I think that's a reference to Breakfast at Tiffany's. Did not mean to do that. FNAF 61, Freddy B. Bonnie, the beginning of the FNAF cinematic universe. There's not here. Okay, we're gonna try to avoid those because they're so unpredictable. Here it is. Okay, here's our next cupcake. Now one of the hidden cupcakes is in like a really stupid spot. I'll show you what I mean. No jerks. I'm gonna die for that. Boom. Yeah. And 2 hearts. That's nice. You can just drop down here, get hit by that. Now you have double jump. And then what we're going to do here is we're just going to fall because it's faster. And quite frankly, I couldn't be bothered. Okay. Now we got... So we have 2 more in this area and then 2 in the industrial area. So one of them we just have to go the other way. So you know how we went one way? Now we gotta go the other. It'll be down here. Oh, that was meant to do dash. Okay, these controls are a little confusing. Okay. There we go, see? And then now you have, so to beat the game, like, officially, you have to do this minigame 4 times, or 3 times. 1, so you have where you get all the cupcakes, you have where you get more than 1, but, or where you get more than 0, but less than 7, or 9 cupcakes. And then the final one, you have to get, you have to beat it with no cupcakes. Haha, take that. Okay, now you'll see what I mean by, like, it's kind of scummy where this first one is. Ouch. Okay, well, I'm doing better than I was last time. Last time I was at, like, 18 health at this point. That was stupid. I was not playing my cards well. That's what you get. It's a little annoying. Actually, just playing this minigame is really annoying, but, you know, what can you do, right? Alright, so now we're at the start. We're almost at the start. Starts up here. Alright, and then once you're here, because we spawned in this room, you have to go up here, then you have to go here, and there is the cupcake. So normally, let's say if you're here and you jump, oh, I guess, okay, there's a regular jump boost too. You're usually not able to get there at the start. Also, you used to have to spam for this to shoot quickly, but not anymore. Should be right over here. Right here. Wrong. I think you missed it back there. Oh, there's a secret here. Here's the second to last cupcake. Then if you go here, the last one is right there. You should be able to just power through. And once you're here at the... Oh, okay, they changed this. This is new. You should still just be able to power through. Right? You stand here, because then his shots can't get you. I guess they changed the game, because usually he can't get you from there. Oh, they made him harder. Isn't that... Okay, we're going to take a break from Freddy and Space. We are going to go do the Chica's World minigame. There's one there. Yeah. Okay, low bites. Oh, we're close. I need to figure out how to get in that area. See, we got one of the new characters so far. And he will be replacing our team soon. Well, all of the Halloween characters will be replacing our team soon. Lolbit is really helpful though. And these guys did help. I basically used this team, Spring Bonnie instead of the Marionette, to win. Is this the computer? No, it's Foxy.
What's this, a space shooter?
How do we... Oh, there was a speedrun technique to skip all these.
Let's kick this party into high gear.
Okay, now we need to retain as much health as we can.
Souldozer! I should have known it was you. You're not even in the right game.
I wasn't fully appreciated in my last outing. Now I'm back to
Show you my full
power.
Well, we're here to take back what's ours. This will be your last cameo.
So this one you only need to play twice. You need to play to, what is it called? You need to play to get an A rank, and then you need to play to get a C rank.
Sorry, I'm not sure what came over me.
For those who get the reference, it's a ball knowledge. So we're just gonna try to take as least damage as possible. We took 3 hits already, and there's a specific weapon we want. Also, I played Endless like 5 times trying to 100% it, but I didn't know that I didn't have to because there was a dedicated mode. But, you know, we learned. Now, this is going to sound a little annoying. So apologies in advance, but it will sound really annoying. As you can see, it does a ton of damage. But you don't have to punch. That's okay.
Oh my god.
Get harder than my voice, I like these jokes. They're funny. And let me not pick up that new one, because we want to keep the one we have right now. Okay, now we just... Okay, this is going to take a while. Not mean to grab that. Okay, we get a Chica. Oh, I hope I don't get a B rank. What's a fourth of 150? I'm gonna go for C rank. Okay, so now as long as I don't die, I get 7 hits. I get 6 hits. Get 5 hits, 4 hits. Okay, let's see. I hope there's no B rank or F rank. Yeah, I hope there isn't a D rank or F rank, because otherwise I just...
Great job, guys. Gals. I see the processing core. Let's blow it up and get out of here.
How is that a B? Okay, we got Janko Chica. Hold on. Hold on. We're doing our research. Oh, it's just a B or worse. Okay. Okay. You will probably replace Fredbear. Yeah. So, or phone guy, I guess. Yeah, phone guy really wasn't. Except for the wall, but I have wall auto already, so he's pretty useless right now. I think I might replace Dreadbear. Or actually, no. Sorry, phone guy. Alright. Foxy Fighters. My code was strict from me being used for... I can't help you without it. Okay. We're getting lucky. Thank you, Toy Chica.
Sorry I'm late, but I'm fashionably. Let's kick this party into high gear.
Okay, guys, come on. Okay, so all we need to do is just be careful.
Souldozer! I should have known it was you. You're not even in the right
Okay,
game.
we're just gonna let this die.
I wasn't fully appreciated in my last outing, but now I'm back to show you my full power.
Well, we're here to take back what's ours. This will be your last cameo.
If it's 5. So we have 30 health total. Divided by 4 is roughly 7. Times 5, 35. Okay, so roughly we need to have 125 health. No, 115.
Sorry, I'm not sure what came over me.
There we go. This is what we want. A lot of Scott's games feel like, I don't know, spam. Oof. I'm surprised those are missing. Ready?
You won't get tired of my voice, will you? You won't get tired of my voice, will you? You won't get tired of my voice, will you? You won't get tired of my voice, will you? You won't get tired of my voice, will you?
You won't get tired of my voice, will you?
Definitely not getting tired of your voice. Okay, that was pretty good actually. That was good 2 damage. that should be an A rank. Yeah, there we go, and we get Balloon Boy. Let's see, what are your skills? Omega Bite. And debuffs. Balloons, Bubble Breath, Munchies. I think you replace Fredbear. But don't worry, Fredbear. I'm putting you on the other team. You're replacing Dreadbear. I love the skin too. That's another reason why I'm so sad that we have to... It's so creepy. Let's look at... I need to get this one. Okay, let's see here. It's... Kudos for looking like Scott style. I don't want it. So goofy. Let's see. Yeah. Mango doesn't have any skins. I have no idea what this is. Nightbear instead of Nightmare. Alright, no cool skins for these guys, unfortunately. Okay, now, how do we get there? I have a guess. And actually, I'm not gonna bother to look it up. Munchies. Nice. I don't know if I like the five laps at Freddy's look. We're gonna look it up. How to get to Chica's Magic Rainbow. Walk through the path of false trees to the left. Alright. Fourth wall. Holy. El Chippo. Whole place is a graveyard of terrible ideas. This portal in particular goes to something unthinkable. A game called Chica's Magic Rainbow. Don't try to salvage my code from it. It's a lost cause. Okay, well, how about you let me? Come on. Let's see. Will it work? I did on one of them. Fourth wall. Slow down. Bust off. Fourth wall. I really like the cover because you can tank like a heavy hit, maybe long enough to get some debuffs down.
Welcome to my happy fun rainbow land. Let's start with something simple. Oops. Simple for most people, I guess. I have faith in you. You can do it!
Okay, hold on. So it's
Come on, you can do
okay.
it!
So it's here. There. Okay.
Aw, don't give up. You'll get it eventually.
And here. Here.
Is this your first time to play a video? Excuse me, is this your first time playing? But really, they don't pay me by the hour, so, keep up the good work, Spore. Oh, it's so cute when kids try to play games.
Okay. What?
Whoopsie.
Okay. I think I get it.
Wow, what a moron. You suck.
Okay. Then you have to jump there. This is just a Super Mario cat.
You suck.
Okay. Can you?
You still suck.
Goodness.
Oh, I'm laughing at you, not with you. Learn to play.
I'm trying.
Back to school.
Okay.
Ugh. Wrecked.
Okay. I think
Rob.
I should look up a speed run. Let's see.
Noob.
Oh, because you can't jump there because it'll kill you.
Newbie booby.
Again.
Booby. Ah,
What?
poser.
Okay. Then here. Okay. Here. And see, so you have to jump somewhere there. Okay. Here. Oh.
Yeah, get some skills and call me in, dammit. That's so sad, it's hilarious. I'm losing patience with you. This is your last chance. I'm gonna kill you! You still suck.
Oh, you got a limited amount of lives? Okay.
Welcome to my happy fun rainbow land. Let's start with something simple.
Okay. We're learning. Oof.
Oops. Simple for most. I have faith in you. You can do
Come on.
it.
Okay.
Come on, you can do it.
Okay. Need to watch out. Come on, checkpoint. Okay.
Aw, don't give up.
Okay.
You'll get it eventually.
Okay.
Is this your first time
Come
to
on.
play a video game?
Okay.
Excuse me, is this your
Okay,
first
come
time
on.
playing a video game?
Okay.
But really, they
I-
don't pay
okay.
me by the hour,
I jumped
so,
too early. So what we're gonna do is here, jump
Keep
to
up the good work, sport.
the. Come on, guys.
Oh, it's so cute when kids try to play. Whoopsie. Wow, what a moron.
Okay, so I need to hold.
You suck.
Hello.
You
What?
suck.
Okay.
You still suck. Oh, I'm laughing at you, not with you. Learn to play.
I'm doing my best. Okay, so what we're gonna do is one.
Back to
Okay,
school.
that was too close, but we can go here.
Ugh.
Okay, I'm gonna put one hand on the space bar, and the other hand.
Wrecked.
Okay, and then here.
Scrub.
I jumped. I totally jumped over that.
Noob. Newbie booby booby. Ha!
Okay.
Poser.
Need to not let go of the space bar. That's my issue right now. Okay. Okay.
skills and call me in the morning. Damn it.
What did you just call me? Okay.
Pathetic. So sad, it's hilarious. I'm losing patience with you.
I'm trying my best.
This is your last chance. I'm gonna kill you! You still
Darn.
suck.
I didn't know she could go cross-eyed. Okay.
Welcome
But
to
we're
my
learning.
Happy Fun Rainbow Land. Let's start with something simple. Oops. Simple for most people, I guess. I have faith in you. You can do it.
Okay, come on.
Come on.
Not
you
the first
can
jump.
do it. Aw,
Not the first
give
jump. Come on.
up. You'll get it eventually. Is this
Oops.
your first time to play a video? Excuse me, is this your first time playing a video game? But really, they don't pay me by the hour. Keep up the good work, sport!
Stop it.
Oh, it's so cute when kids try to play games.
You can turn the voices off. Okay.
Whoopsie!
Darn.
Wow,
What?
a moron.
Here. Turn on your laser things. Rainbow. Rainbow laser things. There we go.
You suck!
Okay. Come on.
You suck!
Goodness.
You still suck!
Okay. Getting rage baited right now. Come on.
Oh, I'm laughing at you, not with you. Learn to play. Back to school.
Okay, I'm doing my best, okay? Apparently this used to be harder because there was another butterfly. Come on, there we go. Okay. Jump there. Jump there, turn around. Jump again! Checkpoint.
Wrecked. Scrub.
Okay, catch up with me. Alright.
Noob.
I'm gonna need to watch a playthrough of this.
Newbie booby booby.
Catch up with me? Come on. Alright. There we go. Okay.
Poser.
Come on. Okay. Can you not go? Okay, here. Stop. Okay. No.
Yeah, get some skills and call me in the morning.
Okay.
Damn it.
Hey.
Pathetic.
I'm gonna need to watch someone else play this.
So sad, it's hilarious.
Oh my goodness. Okay, I think I'm getting the pace. I'm going crazy because I'm counting fences and like
I'm losing patience with you.
oh my god. Okay,
This is your last chance.
as long as we don't get to this flower.
I'm gonna kill you.
Okay, you got it.
You still suck.
Okay. with our skills,
Welcome
with our
to
knowledge.
My Happy Fun Rainbow Land. Let's start with something simple. Oops. Simple for most people, I guess. I have faith in you. You can do
Okay,
it.
come on.
Come on, you can do it.
Come on.
Aw, don't
Oh
give
my goodness.
up. You'll get it eventually.
Okay, there we go. And boom. Here. Boom.
Is this your first time
Okay.
to play a video game?
Okay. Here. There. And then.
Excuse me, is this your first time playing a video game?
Okay. Stupid butterfly. Alright. Get ahead of it. Okay. Come on. There we go.
But really, they don't
Oh,
pay
so
by
close.
the hour, so
Okay. Come on.
keep up the good work.
What?
sport.
Okay. 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 There we go. Okay.
Oh, it's so cute when kids try to play games. Whoopsie.
Okay, here. Then here. Here. Okay. Okay, now I need you to come over. Yes. Okay. Now do your rainbow laser thingy. Okay. Now. There. Down. Jumping.
Wow, what a moron.
Hey. You know, people usually talk like that when they're self-degrading. Okay. Okay.
You suck.
Okay. It's here. Okay, you jump here. Go here, then you jump up.
You suck.
Okay, so you jump here, here, over here, jump.
You still
Okay,
suck.
here, here, then jump over the logs. Then here, jump
Oh,
up.
I'm laughing at you, not with you.
Okay, then I want to say right here.
Learn to play.
Okay, so like right in front of the flowers. Oh, okay. So like right here.
Back to school.
Okay, I need to figure out how to time that. Here, up here. Okay, so it'll be like right here. Okay, nope. Okay, it'll be here. Go back. Go up. Too slow. Go here. Go here. Go up. Okay. I want to say right here. And there was another one. Okay. I still think there's one more because I have to deal with her eyes. I'm pretty sure.
Noob.
Okay, so you really have to go back. Okay. Here. Now jump up. Deal with that. Go here.
Newbie booby
Okay.
booby.
Really, really back. Go here. Go up and over. Go here. Jump up.
Ha! Poser.
Interesting. I'm gonna turn your voice off.
Oh, really? It's like that. Voices off, you say. Well, now you still suck.
Ah, you're not allowed to turn her voice off. Okay. That's great.
Welcome to my Happy Fun Rainbow Land. Let's start with something simple. Oops. Simple for most people, I guess. I have faith in you. You can do it.
Okay. Rainbow, do your thing. Okay, there we go. Okay, now, if my sources are correct, you don't have another trigger till here. And then one more. Okay. Okay, now you're gonna come here. You're gonna trigger. All right. There we go.
Come on, you can do it!
How did you? Okay, that's a hitbox thing. I don't know what was going on.
Aw, don't
Okay.
give up!
Come here. Okay. Here.
You'll get it
Okay, so you have to jump
eventually.
right after. I forgot. And then one more.
Is this your first time to play a video game?
Goodness. I'd be happy to.
Is this your first time playing a video game?
I'd be happy to, you know.
But really, they
Okay.
don't pay me by the hour, so, keep up the good work, sport!
You actually need to be just a tiny bit behind me.
Oh, it's so cute when kids try to play games! Whoopsie!
Goodness.
Wow, what a moron!
Wow. Okay, and now. Okay. Okay, now we go here, jump over the logs. Right here. Go jump through. And then here.
You suck!
Oh, you jump up and then you go. I get it. Okay. Then here. Jump through. Okay, here. Now you're gonna jump. There we go. Oh, now our eyes are coming.
You
Okay.
suck!
Alright, so not this first patch, but it'll be here. Okay.
You still
Okay.
suck!
At the beginning of the patch and at the end of the patch. So, right about now.
Oh, I'm laughing at you,
Okay, a
not
little
with
earlier
you.
than that. Okay, so it'll be.
Learn to play?
Okay, so jump! Okay.
Back to school!
Come on! Come on.
Dumbass.
Okay, well, I win, so too bad. Okay, now all we have to do is beat it under 3 minutes. I don't know if I'm gonna use you, Mr. Chipper. Sorry. Okay.
Welcome to my happy fun
go, come
Rainbow
on.
Land! Let's start with something simple.
Let's see here. All right, weave, go, weave, here, boom, boom, boom. Okay, on fire. Okay. Then,
Oops!
okay. I
Simple
still don't know how
I
it.
had faith in you!
I still don't know how I did that.
You can
Like that.
do
I
it!
really don't know how I do that. Okay, we did it.
Come on,
Okay.
you can do it!
Come on. Okay, a little further.
Aw,
Okay.
don't give up!
Here. Okay. Catch up to me. Okay.
You'll get it eventually. Is this your first time to play a video game?
Catch up. There we go. Okay. And here. There. Okay. Get to the first butterfly. You could do your rainbow thing. Rainbow thing. There we go. Okay. Just get through these two. There we go. Okay. Stay here.
Excuse me, is this your first time playing a video
Stake here.
But really, they don't pay me by
Need
the
to
hour,
turn
so,
around faster. Another stake here. Okay, I know this section. Get your, get it out of your system.
Keep up the good work, sport.
Thought I jumped high enough. Did not. Okay. And then one more here. Okay. Turn logs. Okay. Jump through here.
Oh, it's
Okay.
so cute when kids try to play games.
Go through there. Jump through the logs. Go here. Up there. Okay. Now, I remember this one. It's the eyes. But you're going to want to jump here.
Oopsie.
A little earlier.
Wow, what a moron.
Okay. You're going to want to jump here.
You
Okay.
suck.
A little earlier.
You suck.
Let's see. Maybe I can get it. I don't know if I can. But,
You still suck.
goodness. Yeah, there, get fooled. Jump here and here,
Oh, I'm laughing
and
at
before
you,
that,
not with
okay.
you.
So,
You still
okay,
suck.
because we ran out of time.
Welcome to my happy fun rainbow land. Let's start with something simple. Oops.
Okay, not too
Simple for
high.
most people, I guess. I have faith in you. You can
Okay, not
do
too
it.
high. Like right here, and then turn around. From here. It doesn't matter. Here. And there. Okay, catch up.
Come on, you
Okay.
can do it.
Okay, catch up. Alright. Past that first butterfly. Catch up. Okay, do your thing, Rainbow. Turn around. There we go. Turn around. There we go. Okay, jump. And then jump. Over to the left. Jump one more time. Here. Okay. Now, come here. Do your rainbow thing. Yes. Okay, here. Then under. Then on top. And then one more time.
Aw,
Darn.
don't give
Okay,
up.
so. Do you say give up?
You'll get it eventually.
Okay, so I went too far, apparently, but I counted the fourth flower. Okay, there. Spikes under. Jump up there. And jump here. Okay. Logs. Coming this way. Now jump here. Jump up here.
Is this your first time to play a video game?
Okay. Okay. Jump here. Up here.
Excuse
That
me,
was
is
too
this
early.
your first time playing a video game?
Okay, how about you stop judging me, okay? You're a talking rainbow.
But really, they don't pay me by the hour, so,
I don't know what that means.
keep up the good
Okay.
work, sport.
Oh my goodness. Oh, we're running out of time. That's the problem.
Oh, it's so cute when kids try to play games. Whoopsie.
Okay. Jump earlier than the first flower. So like here.
Wow.
Or
what
not.
A moron.
Okay.
You suck.
Okay. And then here. Okay. Now. And then jump here. And here. And then let's see one more time. Here. Then turn back. And then so jump.
Damn it.
By 1 second. Oh my gosh. I did not want Mr. Chipper again. We already have him. We got this though. We got this.
Welcome to my happy fun rainbow land. Let's start with something simple. Oops. Simple for most people, I guess. I have faith
shoot.
Do it! Come on, you can
Am I not
do
pressing
it.
D fast enough?
Aw, don't give up. You'll get it eventually.
Okay, am I not pressing D fast enough? Come on.
Is this your first time
Okay,
playing a video
I
game?
see my character looking to the left. Okay, ready? 1, 2, 3.
Excuse me, is this your first time
Okay.
playing a video game?
Come on, we got harder stages to pass. There we go. All right, come here. All right, do your laser thing. All right. One more time, do your laser thing. Trigger it. There. Okay, we get past the first butterfly. Okay. Do your laser thing. Okay. One more.
But really, they
Okay,
don't pay me
so
by the
it's just
hour,
right
so,
here, and then right
keep up
here.
the good work,
Forgot to turn
sport.
around. Then here, turn
Oh,
around.
it's so cute when kids try to play
Here.
games.
Then up here, turn around. Up here, turn around.
See?
Up here, turn around. One more time. Okay. Catch up. There we go. Now we can do that.
Wow, what a moron.
Hey. Okay. Down. Now. Okay. And one more time.
You suck.
That was too low. Okay, I'm out of time.
Oh, really? It's like that. You still suck.
What if I turn the voices up at the end?
Welcome to my happy fun rainbow land. Let's start with something simple. Oops. Simple for most people, I guess. I have
Okay,
faith in
one day
you.
I will be able to just get this.
You
Okay,
can
let's
do
try not to
it.
have that much trouble on this one like we did last time. Okay, and weave. Okay. Oh, okay. Get ahead. Okay, do your rainbow thing again. Okay, now fake out. There. Okay. Turn around the other way, please. Fly this way. There. So now you can do your rainbow stuff. Okay. Turn around there. Okay. Here. Okay, there. Jump.
Come on,
Okay.
you can do it.
Jump. Jump and turn around. Jump one more time. Here. Okay. Come on. Making good time. And jump. Okay, good. Now, logs. Logs there. Jump here. Jump here. Jump up. Let's check my. Alright, go. Come on. I just need to know when to jump, which is right here. And right here. And one more right in front of the flower. And then fake out. And there we go.
I'm gonna kill you.
Haha. Don't have to deal with you until the boss fight. Fire strains, 5 colored orbs. Okay, what time is it? Okay. Let's see. 40th wall. Okay, that's actually really good. What if I should replace you? Or do you all have 40th wall? If so, then it doesn't matter. Jacko Rain. None of you do. Okay. So for now, I want to replace Lolbit. With Dude. Okay, Scott Cawthon. And I will replace Lefty with Lolbit. I actually think Lefty would be better than Spring. Yeah, I think lefty, unfortunately, is better. Or is she? No, string bottom is better, in my opinion. Maybe stats speak differently, but that's what I think. Okay, don't have to deal with that anymore. Alright, let's test our team. Fourth wall. Fourth wall. First wall. Fourth wall. Monkeys. Fourth wall. I'm sorry, I already talked to you, Golden Freddy. Okay, I got Jacko Chica. What are my chips, actually? Fury, Auto Shield, Head Start Cover, Block Unscrew. I could do with an extremely lethal bite. Maybe I should do that. We could take off Head Start Cover, maybe. Okay, now the last one to do is Freddy in space. I'm so gonna get an encounter. Yeah, there we go. What if let's try to do Freddy in space without getting any cupcakes first. So our priority is getting the double jump. We have to get the double jump. So what I heard is you can just, so we need a tank, or I could play differently than the speedrunners, but this is going to take a while basically. Okay, well, we're just going through. Goodness. Okay. My hope is that this will make me appreciate the cupcakes more later. I'm getting tired of having to go back and get them all the time. Priority is the double jump. Oh, shoot. Come on. Oh my gosh. Oh, thank you for the heart. Oh, man. I didn't know you'd be attacking in regular intervals. Okay, wait, actually, yeah, I wasn't even supposed to go this way. Come on. Breakfast at 2 guys. Sweet. Down here, beginning of the Freddy cinematic universe. Get excited. Okay. I just got a notification. Come on. I hate corner bouncers. That's what I'm calling them. He steals everyone's flashlights. What a kidder. Oh, my super still charging. Okay. My gosh, I hate those things. Okay. Alright, I guess the good thing is we get to skip some of the tedious work because we didn't pick up any cupcakes, but they're extremely underpowered right now. I don't know if you guys respond. Come on, get lucky. Give me a heart. Give me a heart. Come on. Let my super recharge. Yeah, this is good. I can kind of farm them. For super, for my super. Maybe he'll give me a heart. Maybe. Oh goodness. Okay, actually, we're just It's that top laser, otherwise I'd just be able to just stand here and then, you know, be happy for days. Shoot. Nice. Okay, so we did the hardest one, and we get the coffee grinder, and we get coffee for it. Invincible for 5 seconds. Prevents party members' health going to the negatives, so he's a healer. Let's see. I'll have you replace Puppet. Okay, now we just have to do the same thing. Oh, what time is it? 7. Oh my goodness. Alright. Actually, I don't want to do that. Okay, I think I'm gonna go do real stuff now. Alright, thanks for tuning in. If not tomorrow, the day after tomorrow, we will be working on Unit 5, which is... Hold on. Unit 5, which is applying derivatives to analyze functions. Doesn't look too difficult. I don't think. This doesn't look that... Well, you know, looks can be deceiving, but we'll try it out later. All right, thanks for watching. Bye-bye.